using slope-intercept form, which is lesson 3.1. We're going to be on page 97, starting problems 1 through 9. We've been practicing with worksheets, and now we're going to see what it looks like in the book. So we're going to start with problem number 1, which is y equals 1/2 x minus 3. We haven't talked too much about slope. We've talked a lot about the operation. Well, it turns out the slope and operation are the same thing. So in this case, we can see that the start value is -3, or what we're now going to call the y-intercept is at -3, and the operation, or the slope, is 1/2. Now that makes it a little bit difficult to graph because each time the counter goes over 1, we have to only go up 1/2. So we're going to do kind of a shortcut, and instead of having the counter go over 1, we're going to have it go over 2. So we're going to go up 1, but then over 2. And that takes us up 1/2 each time, but we don't have to estimate where that 1/2 is. So the slope is how far it goes up divided by how far it goes over. We're no longer going to always count each counter. Sometimes, depending on the slope, we're going to skip some. So I'm just pointing out that if we were to count by 1, we would have had to go up 1/2. Now we're going to still use color and still be focused on x being the counter and y being the recursive routine. So that's what I drew right there, was called a slope triangle. Up 1 and over 2 to get to our next point. So remember, those are the counter numbers, the blue, and the pink is going to be the recursive routine. So we went up 1 and we went over 2. Okay, let's try number 2. Y equals 1 minus 3x. Notice how the start value seems to be out of order. The 1 comes first, and that's because sometimes that's the way it's written, but it's still the start value. Whatever is multiplied by the x is the operation, or the slope. And that tells us to go down 3. So this slope says when we go over 1, we're going to go down 3. And again, that's called a slope triangle. So that's the slope of -1, or -3, excuse me, over 1. It's always the recursive routine on the top of the slope and the counter on the bottom. And what's new is we don't always use a counter of 1. Sometimes we'll use a counter of 1, like in this case, but in the previous problem, the counter was 2. Okay, let's go ahead and try number 3, which is y equals -2/5 x plus 6. So our start value is at 6, and our slope is -2/5. Now -2/5 is going to be really hard to graph if we don't think about slope. If we want the counter to go 1 at a time, then that's going to be counting by 2/5, which is going to be difficult. So we're going to skip some with our counter. So we'll start at 6. And I'll zoom out here in a second so you can see what's going on. But we are on page 97, number 3. So we start at 6. Now we're going to go down 2 and over 5. That's what our slope tells us. Down 2 and over 5. We're going to skip 5 of our counters. Okay, and let's try one more. We're going to do number 4, which is y equals x plus 2. Kind of interesting. You can try this before you see what's going on. I'll move it up here in just a moment. Here we go. So this is number 4 on page 97, y equals x plus 2. The slope is 1 over 1 because there's nothing in front of the x. So we start at 2, and then we just go up 1 and over 1.